Hello, once again, ladies and gentlemen, and welcome to our virtual classroom. Once again, coming from my home. And today, ladies and gentlemen, we are going to be going over lesson 1-2. So at this point, if you haven't done so already, you must pause the video, take out your physical notebook, and have that ready to go. Assuming you have your notebook ready to go, once again, we are going to be in Schoology. And the notes that we're about to see, of course, are there under the notes section. This is our 7th lesson, so you will find that there in the table of contents. And today, we're going to find ourselves go to first 9 weeks work in 1-2, adding and subtracting decimals, adding and subtracting decimals. And once again, we're going to be using our book quite a bit, but I don't believe this lesson is as complex as yesterday's necessarily. Okay. Moving on, ladies and gentlemen, at this point, what I would like for you to do is to once again pause the video for about a minute or so, or however long it takes you, just to copy down the heading and perhaps maybe even some of these things in the bottom as we get started. By the way, this is example number 9 from our textbook, 9A. We are going to be using that as our first example as we review. Let's be honest, this is really a review for most of you, how to add and subtract decimals. Once again, we're going over 1-2, adding and subtracting decimals, numbers 9 through 12. This is our 7th lesson, and this is today's date. So again, I'm going to give you guys a little bit, pause the video. Assuming that you pause the video, that you're ready to go on, I'm going to move on. So with that in mind, let's go over to number 9A in our textbook. Number 9A. Remember that you can always make this larger as you need to. You're going to find some language in this lesson that you may not be familiar with. To try to make it applicable to the real world, they talk about electricity and resistors and the resistance of a current and things like that. So you're going to find that language a lot in this lesson, which I know will kind of confuse some of y'all. Please don't let that confuse you. And as you're watching this video, I recommend that you rewind and rewatch certain parts because in the end of the day, we're simply adding and subtracting decimals. And so let's go down to number 9. Number 9 will be down here in page number 10. And notice how in number 9, we have 8 problems, A through H, that is just adding or subtracting, adding or subtracting. And the question becomes, oh, by the way, look at the language they're using. It says find the sum or difference. In math, the word sum always means addition, and the word difference is one of the words that means subtraction. So if they're asking you to find the difference between two numbers, that means that you need to subtract. We already saw that when talking with about adding integers, positive and negative numbers with different signs. Remember that we find the difference, that means we have to subtract them. And so here we're literally finding the difference between two numbers, meaning we need to subtract. Okay, let's start with that first example. Hopefully you already copied it down. And here we have 3 86/100ths plus 98/100ths. Ladies and gentlemen, whenever you're adding or subtracting, this is very, very important that you line up the place values, that you line up the decimals. It doesn't matter how many digits a number has. You have to make sure that you always put the same place value over the other, meaning you want the ones over the ones, the tens over the tens, the hundreds over the hundreds. If we go the opposite direction, after the decimal, we have the tenths over the tenths, the hundreds over the hundreds, etc. So here we see that both 3 and 0 are in the ones place, so they both have to be over each other. Because we are adding, the order doesn't really matter, but I like to put the larger number, not the one with the most digits necessarily, but the larger number on top. And so notice how do I know it's the ones place? Because they gave me a huge hint. Here's the decimal. The ones place will always be after the decimal, or rather the decimal will always be, the decimal will always be to the right of the ones place. Okay, moving on. So then the 3 and the 0 both go over each other, and then the rest of the numbers just line up together. The 8, 3.8, and the 9 are in the 10th place, and the 6 and the 8 are both in the 100th place. All right, perfect. Ladies and gentlemen, once you've lined them up, now we just follow the rules of addition. Let's go ahead and add them. 8 plus 6 is 14. 9 plus 8. And for those of you that may have forgotten how to add, I will be adding some videos under resources. Once that's ready, I'll let you know that it's ready, and I'll show you where it is. 8 plus 9 is 17, plus 1 is 18. And 3 plus 1 is 4. Now, at any point, ladies and gentlemen, you can always do the second step, which is to just bring the decimal straight down. Keep it lined up wherever it was. That is only for addition and subtraction. Please, please pay attention to this. That is only for addition and subtraction. When we do multiplication and division, you'll see that it is quite different. But so the decimal comes straight down from where it was. It stays lined up. So the answer to 9A would be 4 and 84 hundredths. 4 and 84 hundredths, which hopefully makes perfect sense, because here we have 3. It's about, yeah, it's about whatever. And then right here we add about 1, a little bit less than 1. So that makes sense. Moving on to the next one. You're going to see that I'm going to skip 9B for now. But let's go to 9C, because there's something that I want to show you. Notice that at 9C, we're adding, and there's a decimal involved. And in fact, we're adding an integer, a number without a decimal value, with a decimal. So what do? Well, same thing. We have to line up the place values. We have to line up the decimals. So you might say, well, the integer doesn't have a decimal. It does have a decimal. It has a decimal. It doesn't have a decimal value, but it does have a decimal, and the decimal is always to the right of the ones place. The 6 here is the ones place, meaning that there is a decimal right here. So the 6 is in the ones place, and the 7 is in the ones place. So ladies and gentlemen, I must line those up just like I did here. But Mr. Lugo, that looks weird. I'm not sure I want to do that. You have to. If you don't, you're doing it incorrectly. Okay, so the 6 and the 7 must be lined up. The 2 and the 8 are both in the tens place, so they must be lined up, and everything else just kind of lines up according to that. So here we have 126 plus 87 and 457 thousandths. Now, if it makes you feel better, you can make the decimal visible, because there is a decimal right there, and just put zeros because there is no value there. Let's go ahead and add these. 7 plus 0 is 0 is 7, sorry. 5 plus 0 is 5, 4. Decimal will come straight down, because we are adding. When we add and subtract, decimal will come straight down. That's going to be 13. It's going to be 10 plus 1 is 11. And that's going to be 2. So my final answer will be 213 and 457 thousandths. Okay. If that was confusing to you, I recommend you rewind. Moving on. I don't want this video to be too long. If we go to our actual textbook, notice that we do have subtraction right here. And ladies and gentlemen, subtraction, the order does matter. Now, if we look at 9B, we do have subtraction. And again, the order does matter, meaning the first number that you get must be the number that goes on top, even if the number is less, But since right here, the first number is greater, D also, the first number is greater. In fact, let me do D, not B, because D, I like it more. So 9D, this is 9D, D as in dinosaur. So you'll do 9B on your own. We have 17 minus 8 and 63 hundredths. So again, let's make sure we line up the place values. 17 minus 8. Notice that the 8 and the 7 are both in the ones place, so they're going to be lined up. And 63 hundredths. I know that looks weird, ladies and gentlemen, but it's okay. We can always fill in the zeros. So there is a decimal after the 7, but there is no decimal value because 17 is an integer. Okay, now we can subtract. We can actually subtract now. I cannot take 3 from 0 as it is, so I'm going to borrow. And I can't borrow from the ones place, so I'm going to borrow from the, sorry, there's nothing in the tenths place, so I'm going to borrow from the ones place. That becomes a 6. We borrow 10. But now I can borrow from the tens place. This becomes a 9, and this becomes a 10. You always add 10. You always add 10 when you're borrowing. So 0 plus 10 is 10. So 10 minus 3 is 7. 9 minus 6 is 3. Decimal comes straight down. 6 minus 8, I can't do that. So the 1 becomes a 0, and that becomes a 16. 16 minus 8 is 8. So my final answer would be 8 and 37 hundredths. Obviously, you're going to do the rest on your own, but we've already done 3 of them. Let's go ahead and move on to some of these word problems because these word problems are quite interesting. Let's begin with number 10. Let us begin with number 10 here. And let me make this larger. Okay. Number 10. The total resistance in an electrical circuit, told you dealing with electrical stuff, consisting of 3 heater elements is 14.7 ohms. We'll talk about that in a little bit. The resistance of 2 of the heater elements are 5 and 57 ohms and 4 and 91 hundredth ohms. Sorry. Find the resistance of the third heater element. Ladies and gentlemen, without getting too complicated, the 3 heater elements together must add up to the total resistance. And they give us the total resistance here. The total resistance is in fact 14 and 7/10 ohms. So that means that if you add the other heater elements, they give us 2 of them, 5 and 57 hundredths ohms, plus 4 and 91 hundredths ohms, plus a third one, we should be able to get 4.7. So they're asking, well, what is that third one? So again, we're adding 5 and 57 plus 4 and 91 plus something else together to give us 14 and 7/10. And so, ladies and gentlemen, hopefully you can see it. If you cannot, I want you to practice your adding and subtracting. So I recommend that you first add these 2, add the first 2 heater elements using the same rules that we just did. Once you find the sum of those 2, then you can subtract that from 14.7. So 14.7 minus whatever you have to get the heater element that you're missing. Once again, add the first 2 heater elements, which are right here, 5 and 57 hundredths plus 4 and 91 hundredths. And whatever answer you get, you will subtract that from 14.7. In other words, 14.7 minus whatever you get. And that should get you that heater element. I know some of you guys could have figured that on your own. But again, I just want you to focus on your adding and your subtracting. Moving on to number 11, which again has a lot of electrician stuff or electrical stuff. If you want to try it on your own, you can. You don't have to watch the video. You can pause it here. And then if you're lost, you can try watching it. Anyways, the 3 incoming currents at a node in an electrical circuit measure 3800 amps, 7500 amps, and 2900 amps. 2 of the 3 outgoing currents measure 4800 amps, 6/10 amps. Find the measure of the third outgoing current. And Mr. Lugo, what is going on here? All right. Ladies and gentlemen, what's happening here is that you have 3 currents coming into a node. This one, and this one. And we measure them in amps, but that's not really relevant. So those 3 together, you can think of it as this, that they are all 3 coming together. So we have 3800s. You can add them together to see what is the total current coming into the node. And what do I mean by a node? I just mean that they are coming together, all 3 of them, into a little node. Okay, think of 3 different wires coming together, and then they kind of meet together somewhere. So obviously, to get the total, you have to add those 3. That will give you your total. So yes, please go ahead and add those 3. Now, coming out of the node, you should have the same amount of current as what is going in. So whatever the total is will also come out, but it's coming out in 3 different directions. And in one of those, we have 48 amps or 48 hundredths amps. So 48. So out of the total, which we don't know yet, you're going to add those three. We're going to take away 48 hundredths, which is going to go this way. So subtract. And then we're also going to take away 6/10 avs, 6/10. And after that, there's going to be a certain amount that is left over. Because again, these three coming out must equal what is coming in. So we need to figure out what is that is missing. So again, we have three currents coming in. We need to get the total. We need to get the total. So add them together to get the total. Once you get the total, you need to subtract the ones that are coming out. You can either add these two and then subtract that from the total, or just get the total, subtract 48 hundredths, and then subtract 6/10 from that. And then whatever's left over, that is the remaining current that is also coming out. Hopefully that isn't too confusing. Please work together or ask the sub. Hopefully they can help you. And finally, ladies and gentlemen, we move on to number 12, which is actually a lot simpler than it's going to look. This one has to do with going to a restaurant. So you're at a restaurant, or rather, Mark and Marcus at a diner in a restaurant, or ate dinner. Sorry, Mark and Marcus ate dinner at in a restaurant. Mark's meal cost $37.16. Okay, Marcus's meal costs $3.68 less. Okay, so just subtract this from 34.16 cents to get Marcus's meal. Cool. Obviously, once you get that, you'll know the cost of Marcus's meal. The sales tax on the two meals was $4.52. Not a problem. Just whatever, you're gonna add the cost of the two meals and then add the sales tax. That's gonna be the total cost of the dinner. Mark paid with a $100 bill. Cool. How much change did he receive? Yeah. So then once you know the total cost of the dinner, you know Mark's meal, you can figure out Marcus's meal. You add the tax to that. You just subtract that from 100 and you get the change. So hopefully that's not too confusing. Again, they give you Mark's cost. You can easily figure out Marcus's cost by simply subtracting this from Mark's. So that's going to be a certain dollar amount. You can add those once you figure out what Marcus's meal is. After subtracting whatever you get, you're going to add that to 34.16 to get the cost of the meal. Add the tax, which they give to you. So don't let the word tax freak you out. They give it to you. And then subtract a lot of that from 100. Remember that 100 is an integer. There is a decimal there. So when you're subtracting, make sure that you do line it up according to that decimal. Ladies and gentlemen, I hope you found this video helpful. And with that in mind, I will see you next time.